Hello YouTube, RJ. Today got some stuff in from AliExpress. It's all parts for a new project we're going to start. So let's get in, see what we got, and then I can talk about the project and we can kind of start working on that. Let's get some stuff opened up. So first, let's open up this bag. Get some of these things out. Okay. What we got here, got some ribbon cables. So these are 24-pin IDE style ribbon cables, or JTAG cables sometimes. Some people call them that. And what do we got here? We have a pack of 20 connectors for these cables that we're going to need. Then here, what do I have? I have a pack of SN75 160 chips we're going to be using. And what those are, well, let me get this open. And then I got these. These are a bunch of HPIB, or called GPIB, or IEEE 488 connectors, male headers or male connectors. And what this stuff has to do with each other, and what do we have here? I think, hey, that's my 161s. That's in 75 161 BN. So these two sets of chips are drivers for what we're going to build. And this connector, if you do a lot of electronics, play around with old electronic meters and such, you'll probably recognize. Let me grab my frequency meter over here. Bring it over. You'll probably recognize it right here off the back of this meter. This is the connector that plugs in here. As you're probably already guessing, the project is, now that I've got a meter that has GPIB interface, my other stuff's all got USB and LAN, local area network. I decided I needed a controller to control GPIB devices. And so I was going to design one, like write some software for microcontroller and such. And I went online, I got to look at it, and I found out there's quite a few open source projects out there already. So I looked at a number of them. I saw some, and I saw one I really liked, and I liked how one particular guy I saw had made it happen. I was going to just order some boards for it, but I couldn't find anybody that had boards for it. They had the project, but you either just took wires and stripped them and soldered them on a perf board, or you made your own boards or whatever. So I said, I'll make my own boards then. I won't design the software and such. It's already done. And the project I found was called AR488. And I'll show it here on the computer in just a second. It looks like a really neat project. People have done a lot of good work with it. And, I could have bought a pre-done device, but some of them are very expensive if you buy the real thing. I can get some GPIB to USB clones of the National Instrument one on AliExpress for like $35, but they're clones. They don't work with newer software that NI put out. But in the end, being a DIY guy, I just wanted to build my own. The other thing is, if you go the route of the professionally made ones, you end up using these GPIB cables, which I'll show you images of, which are very heavy, they're expensive, they're very inflexible, take up a lot of space in the back of your equipment, such. And when I saw one of the guys work with AR488 in the version he did, he used these ribbon cables to daisy chain. He made little boards that connected to the back of the meters, and he daisy chained it with these to his own controller. The whole AR488 project just uses a little Arduino. You can use just a Nano. You don't have to have anything fancy. and it interfaces you USB from your computer to be able to control your equipment. So that's what we're going to build. And so let me jump over to the computer. I'll show you kind of what the AR488 program is, and then I'll show you the boards I'm designing. Okay, so what is the AR488 project? Well, you can find that on GitHub. It's under Twilight Logic AR488. It seems to be a very, very well supported project, well documented. One of the reasons that I chose this particular project over some of the others. There's a number of ways that you can build this thing. You can build it with the SM75160 and the SM75161 transceiver integrated circuits, or you can just straight wire it. It doesn't have the drive it needs to drive the full amount of devices. If you power off the controller, it will short the bus and cause problems if you have multiple controllers. There's a few things. When I looked into it, going through AliExpress, I could get 10 of each of these chips for less than $10, I think it was. So going that route, they're cheap. The biggest concern here is a lot of people say, well, the chips are expensive. And if you go to Mouser and buy genuine Mouser straight from the source of these chips, you will pay $6, $7 a piece. So you're going to have, $12, $16 in just 2 chips to build this project. So it does add quite a bit to the cost percentage-wise. It's still a cheap device. But going AliExpress, they may even be fakes or knockoffs. I won't be surprised. I expect they probably are. But as long as they work, we don't care. This is not a critical device in the way this is used. It's just a buffer, a tri-stated buffer. So as long as it works, we don't need to meet really tight specs and such. So I'm not worried about that. So I decided I would go ahead and do it right and put the transceiver chips on there. Now, the other thing is this project also has a very well documented manual. Instead of just the GitHub kind of figure it out, they have this great manual, quite long, talks about a lot of different options and using the different Arduinos, and it gives you the wiring, it talks about all the ins and outs, software and all that. Very good. This kind of put it over the top that this is seems to be the best documented do-it-yourself project, open source project for GPIB. That pulled me in. And then the other thing that put me over the across the line to go with that one is this right here. This gentleman did up the AR488. He made his own little non-printed circuit board. He kind of made his own perf board type setup with jumpers and stuff. I think it's a home-built PCB is what it is, but it has a lot of wired jumpers. It's out of focus in this picture, but there's wires running all over. Somewhere he got these boards. Somebody made a few of these boards up here. I couldn't find them available anymore, but what it does is it plugs in the back of your device. This is that GIPB 488 connector plugged in, and then it just has 2 sockets for these ribbon cables, and you just daisy chain your devices. And the last one comes on down and plugs into your controller here, with your little nano, and it controls it. So it's a neat little project. So I thought I'd go ahead and build my own boards version of these and a board for this. Try to kind of come up with a case for it, make it nice. And so that's kind of what got me. I saw this and I said, man, I like that. It doesn't put a lot of space to the back of this. It's not, expensive cables. It's not hard to manipulate. And when I say that, here's what I mean. If you go with the other projects, they use the actual cables. And here's what the GIPB cables, if you're not familiar with them, look. They're quite substantial cables. They're pretty stiff. They stick out. They're double interfaces. So basically your next cable, this would plug into your meter, and then the next cable would plug into this side and daisy on down. So you have 2 of these connected together hanging off the back of your meter. These are stiff. These cables are not cheap. There's limits on the links they have available. So for that reason, it was so much cheaper and so much neater, shorter in the back. Your meter doesn't have to come out as far. I just like the layout the guy did. So that's kind of how I decided to go. So let me show you what I did from that point. So I went in dip trace, and what I did is I went ahead and created a schematic, got my different components, did up a schematic. This is just the GIPB connector and the ribbon cable connectors. And I just did up a schematic. And then from that, I turned around and created a PCB. So I created this PCB. This is just your GIPB connector to go in the device. And here's your 2 IDE cable connectors. And it's just a pass-through. One goes to the other. It interfaces the same pins here. Pretty straightforward. And so here we can look at what it looks like. So here's what it looks like in the visualizer. There's your plug to go in the back, and here's your IDE connectors. 2 boards I'm having built. I'm going to start on the controller today. Now that I've got the parts here, I'll start working on the controller. So I'm going to get this designed and sent off to the board house. I was thinking about trying DigiKey, but when I really got into it, it was going to be, even considering tariffs and extra fees from the shippers and such, it still was going to be substantially more money to go to DigiKey local. So I went out and did a bid out of having these boards made, estimating the other size of the other board, and went out and sent out a bid on, there's a website that will send it out and bid the cost out to a whole bunch of board houses all over, including the US. And they were all coming in way more expensive. I was still cheaper to go to PCBWay and have them do it, pay the tariffs and the extra fees for the shipping, and I would get the boards back quicker. So unfortunately, that's kind of where we are, at least at this point. I'm not seeing a cheaper way out of it or a better way out of it. It's not like a tiny difference either, by the way. We're talking about, to have this board alone right here built at DigiKey, getting only 4 of these boards would cost me about $69. And I can get 10 of these boards from PCBWay, get them in about a third the time, and it's going to come out to be about $49. So, I mean, I'm getting over twice as many boards, which means I can put some in the store. If there's anybody that needs the same thing and wants to build this little project, I can have some spares, throw it in the store, and still pay less to PCBWay, shipping and all, tariffs, everything, than just getting 4 from DigiKey. The other places I priced out was even more expensive than DigiKey. That's kind of where we're at this point. Probably going to be getting these from PCBWay. I've got to get the controller with the Arduino and the the SN75 chips laid out. I'm going to do that today, so I'll kind of take you along, let you share just kind of a brief little how I get started and how I do it. Okay, here I am in Dip Trace Schematic Capture, and I've been generating the schematic to create the board. I'm just finishing up. I'm putting the last trace, and I thought I would capture this and show you the process. I pull in my devices, I wire them up. In fact, I'm going to go ahead and wire up the last connection, and that is I need D12. Let me look here. I need D13 here, connected to the DC, or pin 11, and I'll go ahead and save that because this is done. So what you have here is, this is your Arduino Nano, and you've got your SN75160BN and your SN75161BN chip here. These are your octal drivers for your RS488 bus. And so you have your inputs coming in from the Nano, and then they're buffered. They come out to your RS488 connector, the 24-pin connector. But in my case, this is just the flat ribbon cable connector, because the flat ribbon will run to our adapter board, which connects to the actual RS488 connector. So now that I've got that done, I can go in here and go tell it to convert it to a PC for me. And it will do so. It'll be just a mess, of course. At this point, you have to start working on putting the chips the way you want them, spacing wise and such, and the connector, and making sure everything's pointed the way you want. That's what you do at this point, and then you start routing. You've got your net lines. You can see where your rat lines showing you where you need things, and of course we can design out the board however we want. So at this point, I will start figuring out board size and spacing and make sure these connectors are turned the way I want them, and I'll start routing my connections. Take me a little while, a couple hours probably to get it done. I'll come back and show you what I ended up with at that point. So here we are. I finished up the layout of this board for the controller, and one thing you might notice is the connector is on the other side. In fact, it says it right here to make sure you put it on the right side of the board. So let's try a 3D preview here and see if we can take a look at what the board looks like. Okay, so here's our controller. That's what it's going to look like. And the connector for the ribbon cable is on the back of the board. And the reason for that is I'm going to do a 3D case where you have a hole for this to protrude up through the 3D printed case. Very small standoffs, just high enough to clear the cutoff pins of these components. And that'll let me protrude that through the case so you can plug your cable in. And if I did it on this side, I'd have to have all the heights of these components. This thing wouldn't protrude through the case, so I did it on this side. On this end, what I'm going to do is I stuck it out a little bit off the board. I'm going to have holes just the right size for this when you get it in. And that way you'll plug in your USB cable on one end of the case, and on the top of the case, you'll plug your ribbon cable in and you're done. I will finish up tweaking on these and I will get them ordered. Hey, thanks for hanging out with me today. And most of all, hope to see you in the next video.